Welcome to Geometric Series Part 3. All right, I've got an example going here, and look at that. It's our old buddy sigma notation. It says determine the sum of this stuff here as k goes from 1 to 25. Well, with all these sigma questions, I think the best thing you can do for yourselves is just write out what does it look like in regular numbers. In other words, let's plug in a few of these k values and see what we get. So the first value for k is 1. So I'm going to have a 5 times 2 raised to the 1 minus 1. All right, plus. Then I'm going to have 5 times 2 raised to the 2 minus 1. All right, k here got bumped up 1. Plus 5 times 2 raised to the 3 minus 1, and so on. Okay, so let's have a little look at what these terms look like. Now, we'll do the exponent stuff first, according to BEDMAS. 2 to the 0 is just 1. 1 times 5 is 5. So there's my first term. Now I've got 2 to the 1, which is 2, and 2 times 5 is 10. And here we got 2 squared, which is 4. 4 times 5 is 20. Well, you know what? This big, bad, scary question doesn't look nearly so scary once you look at the numbers. I mean, really, all we have here is first term is 5. Looks like the r value, I think I'm just doubling each time, so it looks like it's 2. And as far as the number of terms, well, we have a formula for that. We take 25 minus 1, 25 minus 1, and then we have to add 1 to account for the fact that we include both the 1 and the 25. So the n value is 25. So we're adding up 25 terms. Well, we got everything we need. We can go straight to the formula now and say this is the sum of 25 terms, and a is 5 times 1 minus r to the n values. It's a pretty big number, actually, all divided by 1 minus r. Yeah, it is a very big number, so let me just write it out here. If you plug all that into your calculator, you will get 160,772,155. That's quite a big number. This geometric series tend to grow quite quickly. Which leads me to my next example, which is a really cool example. I'm just going to clear the page here. This is a really old geometric series example. It's a pretty cool one. I've heard it from Arab folklore where they talk about something about you get a piece of straw one day and then 2 pieces of straw the next day and then 4 the day after that. But I'm going to modernize it for you have a new job, and this is how you're going to get paid. On day 1, you get paid 1 cent. Now I'm going to write that in dollars, so it's 0.01. So that's day 1's pay. And on day 2, we're going to double the previous day's pay. So you get 2 cents. And on day 3, okay, you get double that, so you get 4 cents. So at this point you go, hey, this doesn't look like I'm going to make much money, and you're going to work for a total of 30 days. So the boss says that is perfect. He's thinking to himself, he's going to get away with paying you a couple of bucks. But let's just see who's going to be laughing at the end. We're going to add all these numbers together. So what we're actually doing looks like this. We're going to take 1 cent and add to it 2 cents and add to it 4 cents. And we're going to keep doing this until we've added up 30 terms. So n is 30, and our first term is 0.01, and our r value here is 2. So we have a formula for that, so let's plug all this in and see who's laughing in 30 days. All right, so we have a, which is 0.01, times 1 minus r raised to the n, so raised to the 30, all divided by 1 minus r. Put brackets around that. And here's what we're going to get. So it's working in dollars here. So here's what the boss owes you in 30 days. It's really kind of cool. $10,737,000, oh, 418, and he owes you 23 cents in addition to that. So that's pretty good for a month's pay. But you sure wouldn't think that when you look at, you're starting off with 1 cent and then 2 cents, but it just grows very incredibly fast. And with that, I've had enough and I'm going to stop. So we'll check in later.